So let's say we're running a business. We want to make a profit in order to stay in business. Otherwise, we're just losing money. So section 3.2, we're going to talk about a few different things, and what we're going to start out with is revenue, cost, and profit. So your revenue is what you make. So if I started a snow cone business, if I don't sell any snow cones, there's nobody giving me any money. That's the revenue. As I sell one, each time I sell one, my customers give me money. That's my revenue. I put that into the cash register. Now, not all of that is profit. I've got some costs associated. I had to buy the ice cream. I had to buy the cones. I've got to get the truck to get there. I've got to pay any other workers that's doing the business. So I have costs involved in doing the business. My profit is the difference between the revenue that I get in and what the cost that I pay out. That's my profit. Okay. So here's their little definition. Let's go over this. The amount of money that a business needs to spend for their operation is known as their cost. That keeps me running. I've got to pay my cost. The amount of money that customers pay them for their goods or services is called the revenue. The difference between these two numbers is the amount of money that a company makes or loses, which is called the profit. When a company is making money, which is the goal, the profit will be positive. What is the relationship between revenue and cost when this happens? The revenue is greater than the cost. I've got more money coming in than I'm paying out for the things like the cones and the ice cream. Here is a little table. I'm going to put this up here. Here's a little table in Excel, and it basically gives me all the different things that builds up my cost. So here it is. If I don't sell any snow cones, I'm not using any cups, cost of my cups, so that's zero. The amount of syrup I use, here's the things, here's the ice, I don't use any ice. So all of these are my per unit cost. For each one I have associated with those costs or per unit cost. So it always deals with just the product that I'm building. I also have fixed cost. My fixed cost is that I've got to pay the truck no matter whether I sell one or not. So those are my fixed costs. The total cost in this spreadsheet is the sum of my cost for my unit, all the things that I need to build a snow cone. The fixed cost is always going to be there no matter whether I sell them or not. That's going to give me my total cost. My revenue, I'm not going to make any revenue, so my net profit is going to be my revenue, 0, minus my total cost of $245, so my net profit is negative $245. So here they built out, they say, okay, if I'm going to sell 100 snow cones, I need to do 100 cups. The cost of the cups would be $1, so it's obviously the 10 cents, the penny a piece. 200 ounces of syrup, which is going to cost me $4. 500 ounces of ice, that's going to cost of the ice is the $7. The combined supply cost, that's the $12. That's to make the 100 snow cones. My fixed cost is still $245. So these sums are my total cost. My revenue now, I'm going to sell these things, the 100, 75 cents a piece. I make $75. My net profit is a negative 182 at that point. 200 snow cones, this is what I sell. It's going to cost me the 200 cups, 400 ounces, 1,000 ounces of ice. My combined supply cost would be 24. Here is my total cost, my fixed plus my per unit cost. And my revenue, now I'm going to make the $150. My net profit is negative 119. I continue with this all the way through till I start showing a profit of $70. So if 300 snow cones are sold, how many ounces of syrup are needed? So I would go to the table. I'm going to sell 300. I need 600 ounces. What about if 500 snow cones are sold? I go down here. I'm going to need 1,000 ounces. So this table builds out everything that I need as far as my business cost and my revenue and my net profit. So a formula was typed into cell D5 to obtain the result you use to answer question 2. What formula would give the correct result? So here, the 600, so they're just saying what would be this value. It would be A5, the number of snow cones, times 2. So I'm doubling that, 300 times 2, and that would be the 600. Next one, A6 times 2, the 400 times 2 would give me the 800. So write a verbal description of the relationship between the number of snow cones sold and the number of ounces of syrup that were needed. So the amount of syrup in ounces is the number of snow cones times 2. Each snow cone uses 2 ounces of syrup. So 2 ounces of syrup per snow cone. So those are those rates that we're going to do. So here is our little equation that we're going to start building up. I want to do this in terms of algebra, right? I want to say if X represents the number of snow cones sold, then 2 times that number represents the number of ounces of syrup used. So I can build this little relationship. Tell me X, I multiply it times 2, and that'll be the number of ounces of syrup. So here is just using the letter S to represent the amount of syrup used. The syrup is equal to twice the number of snow cones, and here would be the X. Okay. Does the number of snow cones sold depend on the amount of syrup used? Or does the amount of syrup used depend on the number of snow cones sold? So which one is the independent variable and which one is the dependent? So I need to know the number of snow cones, and then the amount of syrup depends on those numbers. Okay. And your formula from question 6, which is the independent variable, that's our X, that's the number of snow cones, and then S is the dependent, that depends, that's going to give us how much syrup we're going to use. Okay. And again, is this a relationship? Is this a linear, exponential? Remember that growth that's multiplied. This is linear because every increase of 100 snow cones results in syrup increase by 200 ounces. It is every snow cone takes 2 ounces. Okay, so that's that linear relationship. If X represents the number of snow cones sold, what quantity described in the spreadsheet would be represented by 5X? So if we went back, that would have been the amount of ice. So it uses 5 units of ice per snow cone. If 70 snow cones were sold, the value of 5X is 355 times the 70, and that would be the ounces in ice. So if you sell 70 snow cones, you will need 350 ounces of ice. And that, this whole table right here gives everything kind of filled out for you so that you can do per unit cost and all of those and build out for your profit. So if you were to graph the data in columns A and J from the spreadsheet with number of snow cones on the horizontal axis and the total cost, would the graph be aligned? How could you tell? Well, the total cost, if we kept subtracting this out, or basically if we divide 305 by 500, that should be the same thing if I do 293 by 400, 281 by 300. Those should be a constant. So for every, yes, this is a linear because the total cost increases by a constant $12 every time snow cones increases by the 100. Okay. So that constant times this number gives us that one. Okay. If I graph this out as a scatter plot, that's what this looks like, almost a straight line. So that's where this comes from. The y-intercept, the 0 and 245, that gives you that. That gives you the total cost. So your total cost is $245 no matter what this thing is. The cost is going to increase depending on how many snow cones you do, but this was the fixed cost right there. For 0, you had the $245 was your fixed cost. So write a unit rate that describes the combined cost of all the supplies needed for snow cones. So here was the $12 per 100 snow cones is 0.112 cents per snow cone. So here we had worked at this concept of a slope earlier. The slope is just the change in the y value, the change in one divided by the change in the other. That was that rate of change. So here the rate of change looks like the 257 minus 245. That's the change in the y value divided by the change in the x value per 100. That's the 12 cents. So this is the same as the unit rate for supply cost per snow cone sold. Here's just a couple of more examples of writing. If each cup cost 1 penny, $0.01, write an expression for the total cost in dollars of the cuts based on X. It's just 0.01 times X. 0.04 cents per ounce of syrup, or per spent on syrup per each snow cone, not really per ounce, but per the amount you spend per that snow cone. Then the total amount for X snow cones would be 0.04 times X. And then your 7 cents for the ice per snow cone. If you want to represent that, that's 0.07 times X. X is the number of snow cones. If I add all of those together, so these are all my costs for the cost of the cups, the syrup, and the ice. All these involve the same quantity, this X. These are just multipliers, and all I have to do is just add these numbers up. If I wanted to add this plus this to get my total cost for the, not the fixed cost, but the per unit cost. This is just the 0.12, 0.07 plus 0.04 plus 0.01, 0.12. So here's our total cost. The total cost of selling snow cones is the sum of the variable cost. Here's the variable cost. It depends on how many we sell. And then that fixed cost. Those are the things like, and it tells you here, not affected by the number of snow cones sold. It's like the rent, insurance, licensing, all of those things that are spread out that you had to pay to get started, and you're going to pay those whether you sell anything or not. Okay? And this is your cost, a cost function. Okay. So I hope that did some good. We'll see you next time.